All right, so welcome to part 2 of our function review. We're going to focus in on graphs of functions. And it's usually more difficult than function notation and regular stuff. But it really does work the same. So this graph right here represents a function because it's going to take an input, which are the x values. So like this x value right here. And wherever, whatever the y value is that's associated with that is our answer. That is our output. So for instance, if we look at, let's say we were talking about, we wanted to plug in -1 for x. All right, x is how far they are left and right. So x equal -1 is right here. Now what we do to figure out the answer for that is we're gonna draw a vertical line from there until it intersects with the red graph. So here, if we follow that up, we want to know that y value where the red graph is. And in this case, it's this 4. Okay? So not too bad, I guess. If we were to look at f of -11, we're going to go further. Go -11 on x, which is right here. And then this time we're going to be following it down to where it is on that red graph. And we want to know that y value. Well, that y value there is this -5. So there you go. You got 2 of them already. What else do we have? We could answer right here. We could answer f of 6. So if we plug in 6 for x, that gets us right here. But we follow that down. And what's that y value there? It's this -3. You see how far that is up and down. That's what you're after. So it's f of 6 is equal to -3. One that would be a little trickier, I guess, would be f of 10. So we're plugging in 10 for x. This is equal to 0. All right. So if you go over to 10, all right, so this is like 1, 2, 3, and you go over to where it says x is equal to 10, and you're looking at that red spot right there, well, the y value is how far it is up and down. And that one is up and down none. It's up and down 0. All right. There's that kind of graph. Let's look at this kind here. This is what they would call a discrete graph. Let's look at, I'm trying to pull it up so we can write on it. Interesting. Can't write on it? Well, that's unfortunate. Let me pause the video and figure that out. All right, so I got that graph pulled up, finally. All right, so this is what they call a discrete function. Don't worry about that. All it means is that, it's not continuous like those others are. All right, they're just made up of a few points. So for this, let's say we plug in 4. Nope, not 4. I'm going to come back to that one. Let's say we plug in -2 for x. All right, if we plug in -2 for x, that means we go right about here. That's where -2 is. And we're going to look for where the function is defined. So follow that down to the blue dot right here. And you get this y value. You get -5 back. All right. The function at -1, if you were to look at f of -1, there we go. You follow that up, and you're going to get +3. I guess a tough question would be, what do you have to plug in for x so that you get 0 back? All right. The answer for that would be +3. All right. So if you plug in +3 for x, you're right here. And the y value at that spot is 0. Now, let me look back at this f of 4. The reason I was saving this is because there's 2 possible answers. All right. If you plug in 4 for x, you could get, -2. Or you could get +4. All right. This input, this one x value, gives you 2 possible answers. And that is why this graph of these little plotted points does not represent a function. This is not a function because when you plugged in 4 for x, you got 2 answers back. And to be a function, every input must go to only one output. Okay, let's look at the domain and range. So remember, domain, those are your set of inputs, all the things that you were plugging in for x or that you are allowed to. So for this one, for our domain, I'm just going to list them out, no order here. You can plug in 4 for x, that's right here, because the function is defined there. You can plug in 3 for x, that's right here. You could plug in 1 for x. You can't plug in 0 because there's no blue dot here at 0 for x. You can plug in -1, and you can plug in -2. All right, that's your domain. The range are going to be those y values. You're looking at the up and down for it. All right, -5, that's in there. -2, that's in there. It's actually there twice. 0 is there. All right, so -5, -2, 0. 3 is in your range. All right. So what I'm doing is I'm kind of looking at it from the bottom upwards, and 4 is also in there. Now, that's our domain and range. I mentioned that it was not a function, and the quick way that you can tell, besides looking at each input and seeing if it goes to 2 places, is to draw a vertical line all over the place. See right here, if I draw a vertical line and it crosses in 2 spots, that means it's not a function. Let me show you with another one over here. Okay, so here's another one. Oh gosh, I need to be able to scroll here. How can I scroll? Do I need 2 fingers? Yeah, got to use 2. This graph right here is not a function, and the reason why is because of this spot right here. I don't know what that is, maybe 10, that might be 10 for x. But if you draw a vertical line and it crosses the graph more than once, all right, this one only crosses twice, but if there's any place on the graph where you can do that, that means that that graph is not a function. All right, I know it passes the vertical line test right here, but if it doesn't pass anywhere, then it's not a function. So that red one that we were looking at originally, this is a function because no matter where you draw that vertical line, it's only going to cross it in one spot, all right? No matter where you draw it. So you'll have to kind of, I don't know, pretend like you're drawing them. And as long as it passes everywhere, then you're good to go, all right? Let's go ahead and mention that domain and range. Let's look at this. Well, there's not much left to look at. Let's look at this graph that we have here, this red one. All right, so I said the domain were all the x values. All right, and this is a little bit more tricky because it's not just going to be a standard list of numbers. The domain is all the x values. It is. The other way to think about it, since the x values are the ones that go left and right, the domain is going to be all of the, it's going to be how far left it goes, the furthest left, and the furthest right that it goes. So for this one, the domain, furthest left is this -11. All right, that's the furthest left it ever gets. And then the furthest right that it gets is this +10. And you'll see here I'm writing my answer in this interval notation. I put brackets around the -11 because it actually does get there. And the same thing for the 10. It actually does get there. The range is similar. You want the lowest that it ever reaches and then the highest that it ever reaches. So on this one, I believe, well, the highest it goes is that +4 right here. I think the lowest it was, I don't remember what I had there, but maybe it was like -5, something like that. Yep. So this part's not that big of a deal. All right, the domain and range, but I want to kind of make sure you know that it's out there. Domain is how far left and right it goes, and the range is how far up and down it goes. All right, that's good for this one.